As promised, I said I would go through some worked out examples regarding limiting reactants and percent yield. The question that I'm looking at here is one that I actually recommended that you do in your textbook. And while it's not difficult, it's just a little bit different than what we covered in the previous videos. So what we're going to do is take a look at question number 6 on page 339 of your text, and I've sketched it out for you, and we'll go through this step by step, and hopefully with me modeling a few of these examples will give you more confidence as you tackle the problem set. So here we go, number 6 on page 339. Like normal, I've included the balanced equation. So we've got 1 mole of zinc requiring 2 moles of silver nitrate to produce zinc nitrate and silver. This question is difficult in the beginning because they don't give you the balanced equation, and you have to be able to go back and remember your formulas, plug in your equation, balance it. So this is the first part of the problem. Next line, we have the equation line. We have 1 mole of zinc for every 2 moles of silver nitrate. So it's a 1:2 stoichiometric ratio. And we're making 1 mole of zinc nitrate and 2 moles of silver. Now, interestingly, this is not a limiting reactant problem in a sense, because they're telling you that the silver nitrate is in excess. So when you see that, you do not have to do the double calculation in reactants and carry out that check that we looked at previously. It's already known that silver nitrate's in excess, and that's why I've placed excess there. So we have simply 3 grams of zinc, and we can convert that to moles. You've done this before, and we get 0.0459 moles of zinc. Also a little bit different, instead of having you calculate the theoretical yield initially, they're giving you the actual yield. So it's a little bit different. They're telling you what somebody actually achieved when they carried out this experiment in the lab. And our job is to figure out what is the percent yield. So, according to our balanced equation, for every 1 mole of zinc that reacts, we're going to get twice as many moles of silver back. That's why we have this ratio here. This is what we need, this is what we had, and there's our moles of zinc initially, and we get about 0.0917 moles of pure silver. So far nothing is that new, it's just a bit of a different twist on it. We can calculate grams of pure silver, because of course this is a single displacement reaction that you learned before, and we go through that and we get 9.9 grams. That's the calculated yield. You didn't have to do the experiment to conduct that, so we got 9.9. And the last step in the problem is to use our percent yield formula, just like the test analogy where you got 16 out of 20 on a math test. That's 80%. The actual yield is actually given in the problem at the start. That's the 7.2. And the theoretical yield is a number that you just found, 9.9. So when you look at it, the final answer to this question is a 73% yield. Not quite as good as the 90 plus that we had hoped for, but in the lab, this is perhaps what that person got. Maybe they weren't as careful as you are in the lab. So there's a worked out problem for you. Again, take a look at how you're solving. I would recommend you use this method. The textbook method works well as well. It's just a bit different than what I teach. And again, I hope this helps you.